What we're going to be talking about in this video is how to do multiplication and division with powers and exponents. If you are, unfamiliar with powers and exponents, excuse me, please go to our channel and watch the video on explaining what powers and exponents, explaining what they are. So let's start with an example, something like 3 squared times 4 to the 6th power. Well, when you're multiplying, I'm gonna change it because I ain't finna do all that calculation. We'll change this to 3. When you're multiplying powers and exponents, excuse me. Remember, you want to remember that you got the base is the big number, and then the exponent is the little number in that corner. So when you're multiplying exponents, the bases have to be the same. So looking at this example, these two bases are not the same. So what are we supposed to do? Excuse me. When the bases are different, essentially, you just have to simplify each power, each expression, and then multiply them from there. So for this example, we got 3 squared, which is 9. So we gotta simplify that. 9 times 4 cubed is gonna be 16 times 4. Where that gonna be, man? 16 times 4. That's like it's gonna be 64. So whatever the answer to this is, y'all let me know in the comments, please. This is the answer to 3 squared times 4 cubed, because 9 is 3 squared. Excuse me. It's just, again, that's for those who are not necessarily into math. This is something that you're gonna really get, especially in algebra. It can be the same value, just put in a different notation. It could be put just in a different way. And you're gonna have to basically be creative in kind of working out problems like this, because 9 is 3 squared. It's just in what we call the simplified form. So 3 squared times, and 64 is 4 cubed, just put in the simplified version. Here's another example. Another way we can write 9 is what? Let's do 9 times 1. It's the same thing, but it's just another way to put it. Then I just thought that would be a good little example. But so 3 squared times 4 cubed, they got different bases. So we had to simplify them, and then we multiply it, and we get the answer. Excuse me. Let's do another example. I'll actually do the calculation at the time. Need a new eraser. Let's do something like 5 cubed times, let's see, 2 squared. So again, going back to the rule for multiplying powers and exponents, if the bases are not, then again, the language is important. When we talk about bases, you just got to know the base is the number on the bottom for right now. That's what we're going to call it. Or the base is also the number that you're going to repeat however many times. But if the bases are not the same, that means we got to simplify it, and then we can move forward answering the problem from there. But we can't do nothing with it like this. That's the first thing to just know. So 5 cubed, that's 5 times 5, which is 25 times 5, that's 125. 125 times 2 squared is 4. 125 times 4, well, that look like it's gonna be 500. And so this is our answer. 5 squared times 2 squared is 500. I hope you can see what's going on here. Again, y'all let me know in the comments if I'm doing some arithmetic incorrectly. Let's do another example. This time, let's say we had something like 5 cubed divided by 5 squared. So now we getting into how to divide powers and powers and exponents. And the rule is still the same for division. If the bases are the same, then we can, let me correct myself. Again, we do this live. It's a little bit different when you divide. So let's just start from the beginning. The first question to ask is, are the bases the same? The answer is yes. So what do we do from here? Now that the bases are the same, we look at what we're doing in the middle right here. We're dividing this. So this is 5 cubed divided by 5 squared. Excuse me. When you're dividing exponents, all you do is you subtract the exponent on top or the numerator. You take that and you subtract the exponent from the denominator. So 3 minus 2 is going to be 1. And you keep the base the same. That look like 51. Yeah, and you keep the base the same. It ain't that much. Again, like I said, I'm gonna try to not do too much for y'all. You know what I'm saying? So it don't get that about it for real. You know, with the division, you just gotta make sure that the basis is the same and that you subtract the exponents. You subtract the exponent of the numerator. You take the exponent of the numerator and you subtract the exponent from the denominator. Let's do a couple more examples. Let's do 3 squared times 3 to the 5th. Same question. It's not a trick. I'm not finna ask you no trick questions. Let me just put it that way too. It is probably what you think it is. So we just go through the same motions. So we start with the base of the number. We ask, look, is the base of these two numbers the same? Well, they are. We got 3 for this base and 3 for this base. So what do we do now? The next thing we do is we look at what we're doing, the operation in between them. So with this one, we multiplying. The only difference between division and multiplication when it comes to powers and exponents, when you multiply, you add the exponents. That's it. When you multiply, you combine, you add the exponents, as long as the bases are the same. So we got the base of 3, so that's not going to change. And then we just add 2 plus 5, which is going to give us 7. So 3 squared times 3 to the 5th power is 3 to the 7th power. All right. Let's do one more. Just kind of drive the point home. Let's do 6 squared divided by 2 cubed. Alright, so first thing we're gonna ask is, again, the bases. First thing to observe, the bases are different. 6 is not 2. So just from that alone, we already know that we gotta stop and simplify this whole thing. 6 squared is just 36. Actually, not equal sign. 36 divided by 2 cubed is 8. That's 8. 8, 16, 24, 32, So it's like 4 and some change. So the answer to 6 squared divided by 2 cubed is 36 divided by 8, whatever that answer is. Supposed to underline that. So that's how you multiply and divide powers and exponents.